Hi everyone, in this video we are going to discuss about how to find the angle between a median and the side, meaning the side on which it is a median. For example, we have a triangle ABC. As you can see in the diagram, side length AB is represented by lowercase c units, side length BC is represented by lowercase a units, and the side length AC is represented by lowercase b units. And angle BAC, which is the angle near the vertex A, that is represented by uppercase A degree or a radian really does not matter. And similarly, angle ABC, which is the angle near the vertex B, is represented by uppercase B, and the angle ACB, which is the angle near the vertex C, is represented by an uppercase C. And let's suppose we have a median AD which joins the vertex A with the midpoint of BC, which is D. So AD is the median on BC. So here in this video we are going to see how we can find out the value of theta. Theta is the angle between BC and the median AD. In order to calculate the value of theta, let's draw a perpendicular from A onto BC. And let's suppose that the perpendicular is AN. And if we think about the right triangle AND, you can see that the angle ADN will be pi minus theta. If angle ADC is equal to theta, then angle ADN will be pi minus theta. Now if we think about cotangent of that angle pi minus theta, so cotangent of pi minus theta would be equal to ND over AN. And now let's try to represent ND in terms of NC and BN, and let's see what we can find out, right? Can we write ND as half of 2 times ND, which is again nothing but half of ND plus ND. And now I'm going to add DC and subtract DC with these NDs that we have right here. So it is going to be like this: half of ND plus DC plus we'll have ND minus DC. And if you think about ND plus DC, the first ND plus DC right here, if you think about this ND plus DC, that is actually equal to NC. And then we also have ND minus DC. Now this ND minus DC, the negative DC, I'm going to write that as negative BD, meaning DC is equal to BD. So I'm going to write it as ND minus BD. And then in the next step, let's write it like this. It would be NC minus, then I'm going to use another parenthesis to say BD minus ND. And from here, what do we get? Well, this is actually half times NC minus, what is BD minus ND? That is actually BN. So now we have found a value for ND, and that has been represented in terms of NC and BN. Now let's use this value in the cotangent ratio there. Let me write on the left hand side here. So what was cotangent of pi minus theta? That was ND over AN. So can we write it as half times NC minus BN, and all of that over AN. Now from here, if we write it as half times NC over AN minus BN over AN, and we can clearly see that this is half times what is NC over AN. Well, if you think about it, NC over AN will be cotangent of C. If you think about the triangle ANC, that's a right triangle, and cotangent of the angle C would be NC over AN minus what is BN over AN. Well, if you look at the right triangle ABN, there BN over AN will be cotangent of the angle B, and we are almost there. Now I'm going to simplify this little bit. So on the left hand side, what we have then? We have cotangent of pi minus theta, that would be negative cotangent of theta. Cotangent of any supplementary angle will be equal to negative of the cotangent of original angle. So that would be negative cotangent of theta is equal to half times cotangent of C minus cotangent of B. And from here, if we multiply both sides by a negative 1, then we are going to have cotangent of theta. The left hand side will become positive as soon as we multiply by a negative 1, and then on the right hand side we are going to have half times. Here the signs will change, so cotangent of B will become positive and cotangent of C will become negative. And from here we can easily say that theta is equal to cotangent inverse of half times cotangent of B minus cotangent of C. So to be able to find the value of theta angle, we need to know the value of the angles B and C. If we know the size of angle B and angle C, then we can easily calculate the value of theta like this. And similarly, if we draw a median from B onto the AC side, let's suppose that median is BE, which makes an angle alpha with the AC side, and to find the value of alpha, it will be the exact same formula. So in this case, we will be dealing with the angle A and C. So here then alpha can be written as cotangent inverse of half of cotangent of C minus cotangent of A. And similarly, if we draw a median from the vertex C onto the side AB, and if that median is CF, which makes an angle beta with the side AB, then the value of beta will be like this. So this is how we can find the angle between the medians and the corresponding sides. The only necessary information here is that we need to know the angles of the triangle. If we have been provided with the angles of the triangle, then we can easily plug in the values right here in these three formula and we can find the angle between the medians and the corresponding sides. I hope everything made sense. Thank you for watching. See you in the next video.